For most of human history, we imagined ourselves near the beginning of the story, not just the beginning of our own story, but the story of everything. Ancient cultures placed humanity at the center of creation. Even as science replaced myth, a quieter assumption lingered, that we were early, that intelligence arose quickly once the universe came into existence. That awareness was a natural and almost immediate outcome of cosmic evolution. But when we examine the evidence carefully, this assumption begins to dissolve. The universe is far older than our instincts suggest. Approximately 13.8 billion years have passed since its beginning. This number is difficult to internalize. It exceeds everyday experience by such a margin that the mind instinctively compresses it. We compare it to clocks, calendars, or lifetimes, but even these metaphors struggle. Civilizations endure for thousands of years. Species persist for millions. Planets remain for billions. The universe measures time in tens of billions of years, and even that may represent only an early chapter. Our planet formed roughly 4.5 billion years ago. That alone makes Earth younger than much of the universe. But intelligent life capable of reflecting on existence appeared far later. For most of Earth's history, there were no observers, no languages, no tools, no technologies, no minds capable of asking where they were or how they came to be. Life itself took time to emerge. Simple organisms appeared relatively early in Earth's history, but complexity did not follow quickly. Multicellular life required billions of additional years. Intelligence capable of reshaping its environment arrived only in the final fraction of planetary time. If Earth's history were a single day, intelligence would appear in the last moments before midnight. This lateness is not a minor detail. It is one of the most important clues we have about how the universe works. If intelligence were easy, it would have appeared sooner. If awareness were a natural and rapid consequence of cosmic evolution, the universe would have been thinking long before we arrived. But the evidence suggests otherwise. The universe spent most of its existence without minds, without reflection, without curiosity. To understand why intelligence arrived so late, we must begin long before Earth existed, long before life was possible. We must begin with the early universe itself. In its earliest moments, the universe was hot, dense, and simple. There were no atoms, no molecules, no chemistry. Only elementary particles and energy interacting under extreme conditions. As the universe expanded and cooled, particles combined. Protons and neutrons formed atomic nuclei. Eventually, electrons joined them, producing the first atoms. Almost all of these atoms were hydrogen and helium. This early universe was chemically impoverished. It lacked the elements required for complexity. There was no carbon to form long molecular chains, no oxygen to enable efficient energy exchange, no nitrogen, phosphorus, or iron. The building blocks of life did not yet exist. These elements had to be created, and the only place capable of creating them was inside stars. Stars are not merely sources of light. They are engines of transformation. In their cores, simple atoms fuse into heavier ones. Hydrogen becomes helium. Helium becomes carbon. Carbon leads to oxygen and beyond. The most massive stars forge elements all the way up to iron. When these stars reach the end of their lives, they explode, scattering their enriched material into space. This process takes time, enormous time. Stars must be born, live, and die. Multiple generations are required. The first stars were massive and short-lived. They burned their fuel quickly and exploded, seeding the surrounding space with heavier elements. Later generations formed from this enriched material. Only after billions of years did enough heavy elements exist to form rocky planets, complex chemistry, and eventually life. In other words, the universe had to grow old before it could even attempt biology. Early in cosmic history, planets like Earth could not exist. There simply were not enough heavy elements. Any planets that formed would have been gas-rich or chemically simple. The ingredients for life were still being manufactured inside stars. This alone delays the possibility of life by billions of years. But chemistry is only the beginning. Even once the necessary elements existed, additional conditions had to be satisfied. Stars had to be stable. Planets had to form in calm regions. Orbits had to be circular rather than chaotic. Temperatures had to remain within narrow limits. Liquid water had to persist for long periods. These are not minor details. They are strict constraints. Many stars burn out quickly or fluctuate violently. Many planetary systems are unstable. Many worlds are exposed to intense radiation or extreme temperatures. Many lose their atmospheres. Many never remain stable long enough for life to gain a foothold. The universe does not rush to create habitable worlds. It creates many failures for every success. Earth was fortunate. It formed around a long-lived star. It occupied a stable orbit. It retained an atmosphere. It developed oceans. It avoided catastrophic disruptions after its early history. But even with these advantages, life did not progress quickly. It advanced slowly, cautiously, over immense spans of time. For billions of years, Earth was dominated by single-celled organisms. They thrived, multiplied, and reshaped the planet's chemistry. But they did not invent tools. They did not build civilizations. They did not ask questions about the universe. Complexity required further transitions, each one uncertain. Cells had to cooperate. Organisms had to differentiate. Ecosystems had to stabilize. Oxygen had to accumulate in the atmosphere. Each step introduced new vulnerabilities. Each step could fail. Many planets may have stalled at early stages. Life may have appeared, but never progressed beyond simplicity. Intelligence is not just life. It is a specific and demanding form of life. It requires nervous systems capable of processing information. It requires long developmental periods. It requires social structures. It requires stable environments that persist long enough for learning and culture to accumulate. Intelligence requires not just survival, but surplus. Earth did not provide these conditions immediately. For much of its history, the planet was hostile to large organisms. Oxygen levels were low. Climate fluctuated dramatically. Impacts were frequent. Only after long periods of relative calm did complex life flourish. Even then, intelligence was not inevitable. Dinosaurs dominated Earth for more than 100 million years. They were diverse, widespread, and successful, but they did not develop advanced technology. Intelligence capable of reshaping the planet emerged only after a mass extinction cleared ecological space for mammals. Chance played a role. Contingency mattered. A single asteroid altered the course of evolution. Had it missed Earth, intelligent life as we know it might never have appeared. This suggests something profound. Intelligence is not the inevitable destination of evolution. It is one of many possible outcomes. When we consider this, the lateness of our arrival begins to make sense. The universe did not delay intelligence intentionally. It simply required a long chain of conditions, each dependent on the previous one. Stars had to age. Elements had to accumulate. Planets had to stabilize. Life had to persist. Complexity had to emerge. Intelligence had to arise. Each step consumed time, enormous time. This means that when we look out into the universe and wonder why we do not see ancient civilizations everywhere, we may be asking the wrong question. Instead of asking why intelligence is absent, we might ask why it exists at all. The universe appears to be structured in a way that allows complexity only after long preparation. Awareness is not an early feature of reality. It is a late one. And that lateness changes how we should think about ourselves. We are not ancient beings in an old universe. We are recent arrivals in a story that has been unfolding for billions of years without witnesses. Most of cosmic history passed without minds to observe it. Most of the universe has never been seen, named, or understood by anything capable of reflection. This realization carries both humility and significance. Humility, because we are not central. Significance, because awareness may be rare. If intelligence took this long to appear here, it may take just as long elsewhere. Many planets may still be in earlier stages. Some may host only simple life. Others may not host life at all. Some may be waiting, as Earth once waited, for the conditions that allow complexity to unfold. If this is true, then intelligent civilizations may be uncommon, not because life is impossible, but because it is slow. The universe may be rich in potential, but patient to an extreme. And this brings us to a deeper question. Even if intelligence does emerge elsewhere, what happens next? Even if intelligence does emerge elsewhere, lateness introduces another problem. Time does not simply delay the arrival of minds. It separates them. Civilizations do not exist forever. Stars may endure for billions of years, but societies do not. A technological civilization may arise, flourish, and vanish in a comparatively brief span. Thousands of years, perhaps millions. Against the age of the universe, this is a blink. If intelligence appears rarely and lasts briefly, then overlap becomes unlikely. Two civilizations could arise in the same galaxy and never encounter one another. One may appear, broadcast for a time, and disappear long before the other emerges. From a cosmic perspective, they pass like faint sparks, separated not only by distance, but by eras. This temporal separation alone could explain much of the silence we observe. When we search the sky, we are not searching the present alone. We are searching the past. Light takes time to travel. Signals weaken as they spread. A message sent from across the galaxy may take tens of thousands of years to arrive. By the time it reaches us, its source may no longer exist. Civilizations evolve, languages change, technologies shift, priorities fade. A society that once transmitted radio waves may abandon them. It may communicate in ways we do not yet recognize, or it may go quiet for reasons unrelated to extinction. Silence does not require disappearance. It requires only discontinuity. Distance magnifies this effect. The Milky Way is vast, roughly 100,000 light-years across. Even at the speed of light, communication across it is slow. Signals spread outward, thinning as they travel. Noise accumulates, stars move, orbits change. The galaxy is not a static backdrop. It is a dynamic system in constant motion. A signal sent today may arrive at a destination that has shifted, transformed, or vanished. We often imagine interstellar communication as simple. Send a signal, receive a reply. But the reality is far more fragile. Communication across cosmic distances is not a conversation. It is a message sent into uncertainty. There is also another possibility, quieter and more unsettling. Advanced civilizations may choose not to announce themselves. To broadcast one's presence to the universe is to reveal location, capability, and existence. A civilization may decide that caution is wiser than curiosity. It may observe without transmitting. It may listen without speaking. It may recognize dangers we have not yet encountered. Our searches assume that others think as we do, that they value expansion, that they desire contact, that they broadcast openly. These assumptions may reflect human psychology rather than universal behavior. The universe does not promise similarity. Different evolutionary paths may produce different priorities. Intelligence does not guarantee curiosity about others. Technology does not require outreach. A civilization may turn inward, exploring its own world, its own mind, its own possibilities, or it may communicate using methods that leave no obvious trace, methods we have not yet learned to detect. Once again, lateness matters. We are beginners at listening. Our instruments are young. Our searches cover only a tiny fraction of possible frequencies, timescales, and methods of communication. We have been listening for decades in a universe that has existed for billions of years. To conclude, absence from such a brief sample would be premature. Still, the silence remains striking. To understand it more deeply, we must widen our perspective further, not just across space, but across cosmic history itself. For most of the universe's existence, life was impossible. There were no stable stars capable of hosting long-lived planets, no heavy elements, no complex chemistry. The universe had to mature before life could even be attempted. Even now, most regions of space are hostile. Galaxies collide, stars explode, radiation floods interstellar space. Life, if it appears at all, does so in sheltered niches. Calm orbits around steady stars, quiet regions of galaxies, rare islands of habitability. Life is not the universe's default state. It is an exception, and intelligence is an exception within that exception. Earth benefited from a long chain of favorable circumstances. A stable star, a protective magnetic field, plate tectonics that recycled nutrients, a large moon that stabilized climate, a relatively calm cosmic neighborhood after early chaos subsided. Remove any one of these, and the outcome may have been very different. None of these conditions were guaranteed. This suggests that intelligence is not merely rare, it is contingent, dependent on a sequence of events that must unfold in the correct order and persist long enough for complexity to arise. Chance matters, timing matters, survival matters. When we recognize how late intelligence appeared here, we also see how easily it might never have appeared at all. Earth spent billions of years as a lifeless rock, then billions more as a world dominated by simple organisms. Intelligence emerged only after countless near failures. From this perspective, the universe is not rushing toward awareness. It is inching toward it. This realization reframes our expectations. We should not assume that the universe is filled with ancient civilizations far older and more advanced than ours. We should not assume that intelligence arises quickly once conditions permit. We should not assume that technological societies are stable or long-lived. Instead, we should consider the possibility that intelligence is a late bloom, that awareness is something the universe achieves slowly, cautiously, and rarely. If this is true, then the present moment becomes extraordinary. We are living during a time when the universe has, in at least one place, become aware of itself. Matter has arranged itself into minds capable of reflection. Atoms have learned to ask questions about their own origin. This is not trivial, it is not common, and it may not last forever. Which brings us to a difficult question. Even if intelligence arises, can it endure? Intelligence brings power. Power brings risk. A civilization capable of altering its environment on a planetary scale is also capable of damaging it. Technologies that allow exploration and communication also allow destruction. The same knowledge that extends life can shorten it. The same tools that unite can divide. The lifespan of a technological civilization may be limited not by cosmic forces, but by internal choices. How it manages power, how it resolves conflict, how it treats its environment, how it balances short-term gain against long-term survival. If most civilizations fail this test, then the universe may be filled with brief flashes of intelligence, moments of awareness that arise, flicker, and vanish, rarely overlapping, rarely communicating, rarely enduring. In such a universe, silence is expected, not because life is absent, but because endurance is difficult. If this is the case, then being late carries a warning. The universe waited a long time to produce awareness, and it may not produce it easily again. Minds capable of understanding the cosmos may be among its rarest outcomes. To arrive late is to arrive with responsibility. There is, however, another way to understand our lateness, a perspective that turns the question around and asks whether we are truly late at all. What if intelligence did not arrive late because it is rare, but because the universe itself is still young? 13.8 billion years feels ancient to us because our lives are short, our civilizations are brief, our memories span only a few generations. But when compared to the full lifespan of stars and galaxies, the universe may still be in its early chapters. Stars like the Sun will continue to shine for billions of years. Some stars will burn steadily for tens or even hundreds of billions of years. Many of the stars that will exist in the distant future have not yet formed. Many planetary systems that could host life do not yet exist. If intelligence tends to arise late in the lifetime of stars and planets, then our appearance now may not be late at all. It may be early. In this view, the universe is not silent because it has failed to produce minds. It is silent because it has only just begun to do so. Early in cosmic history, there were no atoms. Then atoms appeared. There were no stars. Then stars ignited. There were no planets. Then planets formed. There was no life. Then life emerged. There were no minds. Then, eventually, minds appeared. Each step required time. Each step required new conditions. Each step was fragile. If intelligence is among the last steps in this long process, then its rarity today is expected. Awareness may be something the universe produces only after extensive preparation, and we may be witnessing the early stages of that process. From this perspective, the future of the universe could look very different from its past. Billions of years from now, there may be far more planets with the necessary elements, far more stable stars, far more opportunities for life to persist long enough to become complex. The universe may one day be filled with awareness, with civilizations, with minds capable of understanding their place in the cosmos, but that era may lie far ahead of us. If this is true, then the present moment carries unusual significance. Early events can shape long-term outcomes. Early failures can prevent future possibilities. Early successes can establish patterns that endure. To be early is to be influential. If Earth is among the first places where the universe has become aware of itself, then what happens here matters beyond our own survival. It matters to the unfolding story of awareness in the cosmos. This is not a claim of importance in the traditional sense. It is not about dominance or destiny. It is about responsibility. The universe does not guarantee survival. It does not protect intelligence. Awareness, once achieved, must sustain itself. There is no safety net built into the laws of nature. When we consider how long it took for intelligence to appear, we also see how easily it might disappear. Human civilization is young, only a few thousand years old. Our technologies are younger still. We are experimenting with forces that operate on planetary scales without fully understanding their long-term consequences. The universe has given us a narrow window, a period when conditions allow reflection, when the planet remains habitable, when knowledge is expanding rapidly. What we do within this window matters. To recognize our lateness, or our earliness, is to recognize fragility. And fragility carries value. Earth is not merely a place where life exists. It is a place where the universe has, at least once, become capable of reflection. Matter has arranged itself into minds that can wonder, question, and understand. This may not be common. It may not be permanent. But it is real, here and now. When we look into the cosmos and encounter silence, we are not necessarily encountering emptiness. We may be encountering time, vast stretches of time during which awareness has not yet emerged or has already faded. The silence reminds us that intelligence is not the baseline state of the universe. It is a rare condition, a delicate arrangement of matter and energy that took billions of years to appear. If that is true, then how we treat this condition matters. How we treat our world matters. How we treat one another matters. How long we endure matters. Because the universe may not produce awareness easily, and it may not produce it often. We do not yet know whether we are alone. We do not know whether other civilizations exist now, existed long ago, or will exist in the distant future. We do not know whether the universe will one day be filled with minds or remain mostly silent. What we do know is this. At this moment, on this planet, in this small region of a vast universe, matter has become capable of understanding itself. The universe has become aware, at least in one place. Until we hear another voice, this one matters. And until we find another place where the universe can reflect on itself, this one is precious. The universe waited a long time to produce awareness. What happens next is no longer only a matter of time.